my class, I left off 3 examples from 2.7, parent functions and transformations, so I wanted to work these right quick with y'all. The first one is going to be a linear function. We're going to describe the dilation and graph it. So let's graph the parent function first. That would be when x is 0, y is 0, x is 1, y is 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, negative 3, etc. So dotted line for the parent function. This is going to be, when you multiply by a whole number, this is going to be what's called a vertical stretch. And it's a vertical stretch of the parent function y equals x. So what we're going to do is just simply take each point and multiply it by 5. So if we had a point at 1, 1, now it would be 5 times 1, so it would be at 1, 5. 5 times 0 would still be at 0. 5 times negative 1 would be at negative 5. So this is taking and stretching out the function, making it longer and skinnier, would be the best way to describe it. On number 6, this is what we call a vertical compression when we multiply by a fraction. So vertical compression the parent function is y equals the absolute value of x. So since we're taking, well, let's write our parent function first. So absolute value of 0 is 0, of 1 is 1, of 2 is 2, of negative 1 is 1, of negative 2 is 2, etc. So dotted line for the parent function. And then we're going to take and half all of our values for the dilation. Another word or thing to think of when you think of dilation is when you go to the eye doctor and they dilate your pupils and they make them bigger. So dilation is changing the size. Okay, it's making it either longer and skinnier or short and fatter. This one's going to be short and fatter. So I'm going to take half of all the absolute values of x. So I'm just going to take well, first of all, I'd still have a point at 0, 0. But instead of at 2, 2, I would be at 2, 1. And instead of being at negative 2, 2, I'd be at negative 2, 1. I have a point up here at 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, half that would be a 2, half over here would be a negative 2. So you can see that we've kind of scrunched it down, we've compressed it down, pushed it down. The last one is a vertical stretch because we're multiplying by a whole number, or I should say the number greater than 1 or less than negative 1. And the parent function here is y equals x squared. So that's the parabola. We had a point at 0, 0, at 1, 1, at 2, 4. Same thing on the other side, it's just a reflection. So the points are equidistant from the middle. So parent function looks like so. we use, let's say we use 0 in here. 0 squared is 0 times 2 is 0, so we still have a point here. 1 squared is 1 times 2 would be 2, so we have a point at 1, 2. Negative 1 squared is 1 times 2 is 2, so negative 1, 2. And then I can't fit any more points on here, so I'm just going to go ahead and connect these so you can see. Stretching it out is making it longer and skinnier. So those are some descriptions of dilating some parent functions. I hope that you found this easy to understand, and again, have a great day.